Hello everyone, my name is Yongguk Jung and I'm here to talk about simulation tool for urban mobility, which is SUMO. This tool is very specialized simulation tool for the urban mobility and it's open source software. So there are many libraries that you can also use based on this SUMO, but also there are some basic features that we can just follow. So today's video you can just follow and then at the end I will introduce some hands-on demo so that you can create your own simulation model by yourself. This is the agenda for today's video. I will just introduce the general perspective of SUMO and there are some information what is the SUMO and what is the logic behind. And I can introduce basic features so that you can follow and there is at the end there is a session for the SUMO tutorial. I hope you can enjoy this. Before we go into detail about SUMO itself, I can explain the difference between the discrete time and the discrete event simulation. First of all, SUMO is based on discrete time system. So in our real world the system is based on the continuous time. So the system variables in real world, it will change continuously. But in our simulation system, we cannot have this continuous system. So we need to have discrete time or we need to describe the system based on the discrete event. But here, first of all, the discrete time, it means we will have the minimum time span and based on this minimum time span, we will check the system variables regularly. So we will have a specific minimum time span and then we can check the next system variables at the time step. So we will get the system variable or the system status every these steps. But instead of this discrete time in the discrete event system, we will have we can check the system variables based on the specific time when the event has happened. So let's say there are some several events like this, but when the event 0 happened, then the system variable might has been changed, and then we can get the system variables based on this event, and we can assume that there is nothing between these events. So we don't need to check all the system variables between these events. And then there is another thing has happened that we can check the system variables at this t1, which is the time for the event 1. So some systems, for example, the production system or other the queuing system, we don't need to check regularly because we can assume that there is nothing has been changed between the specific time. In that case, we can use this discrete event system. But for example, the traffic simulation, the traffic is a flow, so we need to check regularly. So the SUMO is based on the discrete time system. So what do you need for your simulation model? So you need several XML-based files. So to create an executable SUMO configuration file, which is a simulation file, you need a road network to create as a map, and you also need a traffic demand. So for example, let's say you have two vehicles and the two vehicles will follow this route, and then you need the number of the vehicles and the starting time and starting point and where is the route based on this map. And then if you combine these two input file, and then you will have this executable SUMO simulation environment. Later I will talk about more in detail how to generate the simulation model, but you can see there are different type of XML files. So as I said before, the road network is a basic map, and actually there is an additional file. So you can define the bus stops or the traffic light logics in this additional file, but we will not go in detail about this additional file. But the other one, the traffic demand, you could have the route file. So this route file will define the number of the vehicles and the route and the time as well. And this configuration file is an executable file, and it will define where is your input file as a map and the traffic demands. For someone who doesn't know about the XML, XML it means the extensible markup languages. So you can see more detail about this XML, the basic in this link. In SUMO, there are many different ways to define the traffic demands. The first one is a trip, and the second one is a route. And with the trip, you will define the starting edge as a street, and the destination edge, and the departure time. Route is different. It's an expanded trip, so that means there is a you will define not only the first one and the last edge, but also all the edges the vehicle will pass. So for example, in this case, the trip will include only the starting point and the ending point, but the route will include all the passes that the vehicle will pass, like this. But in many times in traffic simulation, you need to have multiple vehicles. The previous one, trip and the route, you will only have one vehicle. But with this flow, you can have the interval time, the beginning time and the ending time, and the number of the vehicles. So for example, from A to C, and you could have multiple vehicles with regular the time difference, time period. So for example, here you will create this vehicle from edge 0 to edge 1 from this time window, and you will create 100 number of vehicles with this flow. So I will show you some demo how to use the net edit, which is the tool that is included in SUMO package. And within this tool, you can create the road network and traffic demand, and even you can change the lane connections and the traffic light control. But we will not go that in detail this time. So this is net edit. In this net edit, you can draw your road network and traffic demands, and you can also change other parameters here. So I already prepared an example like this. So for example, here with this inspect mode, you can check the variables of your element in your model. So for example, if I click here, you can see the ID and the speed limit and the number of the lanes. If I change these lanes, maybe 3, then you will see the changes like this. But I will change this one to back 1. And the SUMO, it has edge as lane, the traffic network. And when you have multiple edges, then it will be connected based on this junction. So the junction and edge is the basic component of SUMO road network. So we can create this road network. So I can show you how to create it. So first of all, you need to change your mode as an edit network elements. And you can go to the set create edge mode. And then if you cannot see this grid, you can turn on this grid mode. And with this mode, you can just easily create the road network by clicking like this. But as you can see here, it is connected in this way. But because I turned on this edge chain mode and edge opposite direction as well. If I turned off those options, for example, this chain mode, you can create this disconnected edges like this. And if you turn off this edge opposite direction mode, then you can create only the single lane like this. But this is not what we want to do. So I will just delete this, and we can create a network with the chain mode and the opposite direction. So there is no rules how to create the road network, but maybe you can just follow like this. And if you want to, if you don't want to continue to edit based on this, you can just click ESC in your keyboard. And then you can create another road here, and it is automatically connected in this junction. If you want to check it, you can change your mode to the inspect mode, and you can check if this junction has different edges as well. So this is the edge that I have created, and based on this road network, you can create your traffic demand based from this demand mode. So if you go to this demand mode, there are different options that you can create your traffic demand. So for example, there is you can create your route, you can create your vehicle, and you can even create pedestrians as well. But here I will show you how to create the route. So as I explained before, with this route mode, you can define the multiple edges, not just the starting edge and the final edge. So to start defining this edge, the route, you can just click the first edge and can just keep continuing like this. So if I follow this, then my traffic will start from here and it will follow this route. And if you're done with this, you can just click finish route creation. And this is my route. And if you want to add a vehicle based on this route, you can change your mode to the create vehicle mode. And there are different type of vehicles here you can select. But since I already have routes, so I will just click this vehicle over route, and I can assign this route to the last route. So this is assigned in this route. And there is another mode in SUMO. So this vehicle will create the trip. So it will just create a single vehicle like this. But if I change to this flow mode and over route, then there are other options. So in this flow, it will start from the beginning and it will end at 3,600 unit time, and they will create 1,800 vehicles per hour. So maybe I can just adjust 100 vehicles per hour. And I can also assign this flow to the route. So we have two traffic flows. So first one is flow, and the second one is the trip. Here you have, so we have network and traffic demand, and it has different files. So the first one, I need to save the network file. And then the second one is the traffic demand file. So the traffic demand file, the type is like this. And I will save this file as route. And those are the XML format files. So I can easily change this file using the the text editor. So if I open this network file, and you can see the different type of edges like this. But since I already have another edges here and above, so maybe I need to delete some of them. I can remove my edges from this net edit. So let's say I can delete this. Select delete mode. Yes, delete, 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 delete. And I can save this file. and it will be updated here. So now I only have edge from here to, yes, so this is the edge and junction that I saved here. And also the demand file. So I have traffic demand from here. So you can also see the route here. So as I mentioned before, I have created one route and one vehicle, which is following this route. And there is another flow, and it will create the traffic flow from the beginning to the end and 100 vehicles per hour. So based on these two files, you can execute your simulation model. But to do that, you need to have this configuration file. And configuration file is also XML file. So it has this configuration elements, and you need to define input file like this. So I will assign this network file, and you can just make sure your network file name and the route file name is the same as your file name, and you can just save this file. And let's just execute this file. So you can double click this file, and we can see our network file. And you can change this setup as a real world, and you can see like this. And if you just execute this simulation model, maybe it will be too fast. So you can just maybe increase this delay. And if I execute this, we will see two different flows. So this is the trip one, and I can see the first car from the trip. And after for a while, it will generate the traffic flow. So every hour, they will generate the traffic based on the flow. And if you want to adjust this, the number of the traffics, you can change the numbers in this text file. You don't need to change your network. You don't need to change the setup from here. You can just change the parameters in this text file. So if I just change this depart time, maybe in 100, and maybe we can just do that. And I can just change this beginning time as 200. Then we will have one vehicle at 100 unit time, and we will have traffic flow between 200 to 400. And we will see, I can just close this file, and I can execute this file again. So execute this file, and until the 100 unit time, nothing will happen here. And then I have one vehicle here, and it will follow the route one. Since there is no traffic light, it will not stop in this train. And now we have another vehicle from 200, and the flow will generate this vehicle repeatedly until 400. So I have more vehicles until 400 unit time. But after 400 unit time, this simulation will be finished. So this is the last vehicle, and the simulation will be finished. So the simulation ended at 460 simulation unit time.